Hello, this will be a demonstration of proposition 6 from book 8 of Euclid's Elements, which says that if there be any number of numbers in continued proportion or geometric progression or geometric sequence, and the first number does not measure the second number, then the first number will not measure any of the other numbers in that continued proportion. All we're given is some continued proportion. This one is 5 terms long. So A, B, C, D, and E are in continued proportion. That is that A is to B, just as B is to C, just as C is to D, just as D is to E. We're also given that our first number A does not measure our second number B. What we want to prove from this is that the number A does not measure any of the other numbers in our continued proportion. That is that A does not measure C, D, or E. We first want to prove that the number A does not measure the number C, of course. We're going to do this by taking 3 numbers, F, G, and H. And it will be the case that the numbers F, G, and H will be in a continued proportion and will be in the least ratio, or will be the least numbers that are in the same ratio as A, B, and C. So F will be to G just as A is to B, and G will be to H just as B is to C, and F, G, and H will be the least numbers in the same ratio as A, B, and C. We can, of course, create these 3 numbers, F, G, and H, by proposition 733. Now, because F is to G, just as A is to B, and G is to H, just as B is to C, we made them in that way in our first step. We can then say xi quali going through the middle term to compare the extremes directly. We can say that F is to H, just as A is to C. We can obviously say that this is true, that if any number of numbers be proportional xi quali, then, or they will be proportional xi quali. So that's proposition 714. So F is to H just as A is to C. Now next, again, because we know that A is to B just as F is to G, and we know that the number A does not measure the number B, we can then say just simply by the definition of proportionality, definition 720, that F does not measure G either. And of course, because F does not measure G, the number F can't be the unit. That's fairly obvious since the unit measures every number. So if a number doesn't measure a number, it can't be the unit. So F is not the unit. Now, you may be wondering, why the hell is that important? You'll see in the next step. It wasn't obvious to me at first why did we need to prove that F isn't the unit? This is why. Because F is not the unit, and F, G, and H are the least numbers in continued proportion in that ratio, we can then say by proposition 8.3 that the extremes are prime to each other. That is, that F is prime to G. This obviously would not work if F is the unit, because then if the unit cannot be prime to any number. So if F is the unit, then saying that F is prime to H would be impossible. But because we've shown that F is not the unit, we can therefore say actually that F is in fact prime to H. Now because F is prime to H, F of course does not measure H. That's just obvious just from the definition of what it means for 2 numbers to be prime to each other. Now you remember in our second step, we proved that A is to C just as F is to H, and we proved that F does not measure H, which means again by the definition of proportionality, definition 720, we can say that A does not measure C either. Now we can go through a similar method to prove that that A does not measure D and A does not measure E by creating the least numbers in a continued proportion in the same ratio that are an equal number to A through D or A through E. We can go through this whole logic again. Point is that we can prove that the number A does not measure C, D, or E, which is exactly what we wanted to prove, which means we're done with the proposition, therefore, etc., Q, E, D. You know me, I always like to give particular examples of this, of just any proposition dealing with numbers, so let's do that. So I'm going to create a 5-term sequence right now. It'll be in the ratio of 2 to 3. What's that going to look like? So that'd be 16, 24, 36, 54, and the final number would be 81, like that. Now, I know that 16 does not measure 24. 16 is not a part of 24, rather it is parts. So 16 does not measure 24. And what this proposition allows me to say is that 16 will not measure 36, it will not measure 54, and it of course will not measure 81. So that's what this proposition is going to look like with a particular example. That's all I've got to say about this one, so I'll end the video here and move on to proposition 8.7.